Hi everybody, welcome to the part B of the seventh video in the machine learning series. Here we're going to dive into three important algorithms that are used for text mining. You would have probably bumped into at least one of these three names so far in my video lecture series, or you would have heard of these names elsewhere. Keras library, NLTK library, and Scikit-learn. We're going to look at how these really work in Python and what kind of AI magic really happens behind the scenes. Today we will pit each of these algorithms together and we will see a text mining showdown. How these libraries really compare, how do they really work, and what are the differences. Let's start with Keras. Keras does not count the number of words, but it learns the pattern and context from these words. It's a pretty advanced algorithm. It's the most advanced out of these three, and it has the ability to learn patterns. They have created like a tokenizer which fits into the training set, and you could potentially use TF-IDF. And let's dive right into what this TF-IDF represent and how Keras really makes use of the TF-IDF algorithm. All right, let's look at what I did in Python. I got this data set of news article. So these are a bunch of news articles, which we looked in the Excel sheet just now. And graphics is one for those which pertain to like computer related news groups. Hockey is one for the ones that are sports related. Medical would be one for the ones that are medical related. This is the data set we have used to train our algorithm. And how we did that, we're going to learn a little bit in the video. First thing I did is to convert this graphics or news group into ordinal or into numbers. So I converted this graphics using ordinal encoder to zeros. Hockey becomes 1, medical becomes 2. Medical is the end, so I use the news.tail to look at my end of the data set, and I get target as 2. So all I'm going to use is 3 columns, graphic, hockey, and medical as my independent variables, and the dependent, which is the target variable, would be in the form of numbers now. All right, so let's look at the test and train split. So I split the data into test and train using a 70-30% split. And I'm now using the Keras Tokenizer. I need TensorFlow library to run this one. First thing I would do is filter out all these non-meaning words. Example, exclamation mark, plus, minus, greater than, equal to, smaller than, backslash, forward slash, all these things I'm going to get rid of now because I want the clean data. And I limit myself to the highest frequency words, like top highest frequency 500 words. I fit on text using the Keras Tokenizer. So I did something similar to fit transform. And I was just talking about TF-IDF, and this is how TF-IDF is being utilized. So TF-IDF, I'm converting the text to a matrix. So the text in the independent columns is now converted to numbers. And these numbers actually represents the importance of each word in a given set of rows. As we just looked at, computer becomes important for the categories that are graphics. Pediatrician becomes important for the categories or the target variables which are medical. And that's how the algorithm really runs and understands what's hiding in your data set, the patterns in your data set. It's all mathematical, no magic. All right, I did the same thing, text to metrics, in my train and test data set. Here, just to show you how my tokenizer really looks, the Keras tokenizer and the word counts in the Keras tokenizer. So, for example, article came 249 times. I got all these tokens in the Keras tokenizer. And see how big this tokenizer has become after filtering out all the data, all the non-informational words like exclamation mark, greater than, equal to, smaller than, backslash, forward slash. And now I come back to my original algorithm, that's random forest. So I'm using random forest to learn from this, to work on this tokenizers, token data. Note that I've limited the number of columns to just 500 by selecting only the most commonly occurring terms. And know that I haven't created any SVDs single value decomposition in here. You could still do it. If you don't create SVDs, you have so many columns, like 500. If you got like 50,000 columns, you could still work with SVDs and reduce the number of 50,000 columns to just 5,000 columns. So here's the random forest classifier. Why did I use classifier? Because I got 3 variables only in the target column. So I got 0, 1, and 2. 0 representing what the one of the news groups, that is graphic, hockey, and medical. The 3 different categories of the news group. Because I got only 3, I'm using the classifier, not the regressor. And I did this fit, and know that I am using just 300 trees. Random forest is based on the idea of decision trees. I did not define the maximum depth of those trees, and the criteria to find the residual or the errors is the Gini index, and I look at the accuracy of my trained data set. That comes out to be 99%. I do the same on test, which is really what I'm interested in. It comes out to be 82% accurate. Know that 82% is less than 99. That means there is some overfitting. It learned too much from the train, that it did not predict the test as good as it did on the train. All right. I'm going to live with it. If you want, you could reduce the accuracy of trained, increase the accuracy of test, bring this overfitting down by some of the techniques we discussed in the previous videos. You can increase the minimum sample leaf. So you can have 3 or 4 in each of those boxes. You could reduce the number of decision trees even further. And there are other methods to reduce the overfitting. Here's my confusion matrix. And I now try to use another important algorithm, that's stochastic gradient descent classifier. All right, here I look at my accuracy, which is again 99% on the trained data set, but 89% on the test, which is what we are really interested in. So 89% compared to 82%. And I conclude that stochastic gradient descent classifier is predicting with a higher accuracy. And here's my confusion matrix for stochastic gradient descent classifier. Here to see if it really learned good or not. So I'm going to assign the target variable, which is my news group. I split the data set into 70 and 30, the same percentage I did on Keras. And I bring in different libraries of NLTK, Natural Language Toolkit, stopwords, WordNet, OMW, MPU, and KT punct. Note that just for the purpose of this video, I have replaced this punct with tree bank word tokenizer. Is the similar tokenizer that punct would use. Now, once these are imported, once these are downloaded, I ran this filtering algorithm. So in the text, in the data set, I filter out all these items that are not. Then I do the tokenizing using the NLTK tokenizer I got from tree bank word tokenizer, and I do the lemmatizing. We covered lemmatizing previously. For W in words is alpha, when the length is greater than 1, lemmatized with the help of W for W in words. I append the data. All right, I've done the lemmatizing. I've got rid of the stop words, and I got rid of these bunch of non-informational words. Which is my custom tokenizer. So here we have the tokenizer from Keras library, but I created a tokenizer myself here, which works with these rules in mind. All right, I did the testing and training. Testing and training is now being done with the help of 30 and 70% split. So here's my train data set. Here's my the first observation of the first row, that's 0. So article, alchemy, reference, browser, SFU, pasture. So it got rid of a bunch of different stop words like and, it got rid of all grammatical words. I'm going to use the Scikit-learn library to create a term-by-term document matrix. So I'm going to convert these words into numbers. So I used fit transform using TF-IDF Vectorizer. This belonged to Scikit-learn package. I got rid of the stop words. Maximum number of features or columns is going to be 500. These are my 417 rows, 500 columns, 180 rows, 500 columns in the test and train split. I still did not create any SVDs or singular value decomposition, but you can do if you want. Since I had only 500 columns, I could go even higher. But if you have like 50,000 columns, you could use the SVDs and get your columns, 50,000 columns, reduced to just 500 or 5,000. Again, the same idea. I limited the number of columns to just 500. I use scikit-learn.ensemble. So I'm going to do like an ensemble model. I'm going to use random forest classifier, the same algorithm I used on the Keras library. Let's look at how the accuracy compares this time. Using the same algorithm, the random forest with same parameters, uh, I have an improved accuracy of 85% compared to 82% last time. All right, this is my confusion matrix, stochastic gradient classifier. How does this compare to the stochastic gradient classifier on the Keras library? I had 99% accuracy, which is expected on the train data set, not the test. So this is my train again 99%, 99%. But what we are really interested in is the test, how it performed on the data set it did not know previously about. It gave like 87% accuracy. Previously it was 89. So Keras performed better as far as the stochastic gradient classifier is concerned. So these two methods we have covered so far. One is text mining using Keras library and text mining using NLTK, Natural Language Toolkit. All right, last but not the least, we're going to talk about the Scikit-learn package by itself. So what if we did not use NLTK or Keras, just use Scikit-learn, pure Scikit-learn? I do the same idea. Here, this time I got a different data set, which is the products.csv. I got different categories of products, electronics, books, clothing, and accessories, but the idea still remains the same. Here, I split the data set into the same percentage split, 30% and 70%, and I use the same library that I just talked about, that's the scikit-learn for my data preparation. All right. So I'm using the idea of TF-IDF, which is actually a scikit-learn package. Now create a new column, which is copy of the original data frame. I'm creating a copy so that I don't overwrite in the process of learning the original data frame. I'm converting the data frame into a NumPy array. So this is my original data frame. So this is what I'm trying to learn from. These are a bunch of my rows. Again, the same idea. I will have only 500 columns, but here I had so many different words. My columns would have been higher, count would have been higher, but this time I'm going to use the SVDs to reduce the number of my columns to just 500. I have created a data pipeline with the help of function transformer. I create a new column. When I apply this function transformer and all this data goes to my new column, I use the same TF-IDF vectorizer, term frequency, inverse of document frequency. That's what TF-IDF is. Again, it represents the importance of a given term in the overall data set. So for example, pediatrician belongs to medical columns. or computer belongs to graphic columns, TF-IDF gives higher importance to those terms with reference to graphics. So computer would have higher importance in those rows which have graphics as my news group. Pediatrician would have higher importance in those news articles which have medical as my news group. All right, I have my column transformer, and this is my preprocessor. Column transformer is defined as text, text transformer, and text column. Text transformer is this transformer that we just defined, and text column is the text column that has all this description. So this text column goes in text transformer and becomes text, and everything else is dropped out. All right, so all these text have now become into numbers. This is the work of the transformer defined in the preprocessor. And how it transformed based on the TF-IDF vectorizer. All right, we calculate the baseline accuracy. Baseline is just whatever word has the highest frequency in all this in this big data set. You will think all the words are the same. So it picks just the highest frequency word, divided it by all the number of words, and we get an accuracy score of just 38%. And that's expected, 38.6% in test and train. So both did worse. I mean, the train and test accuracy comes out to be poor when we talk about the baseline accuracy. But we are going to use like a classifier or the learning algorithm, which is random forest classifier. We will limit the number of estimators to just 100, maximum loads per leaf, maximum leaf per nodes, 16, and I have an accuracy score of 89%, which is pretty impressive on the test data set, which is even better than Keras and NLTK. But note that this is a different data set that we are working on. But still, point is, even Scikit-learn can learn a lot from the data set using TF-IDF vectorizer. Here's my confusion matrix. I'm going to try another classifier, SGD, stochastic gradient descent classifier. My accuracy is 94% on the test data set, which is pretty impressive again. And here we conclude that we have covered 3 different ways to clean the text or do text mining using Keras, NLTK, and just with Scikit-learn package. And in all these 3 cases, I ran the same classifier algorithm, that is random forest and stochastic gradient descent classifier. And this forms the basis of big machine learning or big deep learning algorithm or text generators like ChatGPT Grok would use as their baseline algorithm. I hope you learned something interesting, and this will be carried further in the future videos.